Good morning. Today we are doing our last objective of the year, and it's going to be kind of a fun one. We are doing CO75. I can compare theoretical probability and experimental probability. So we need to know the difference between theoretical and experimental. In order to do that, we need to know what those words mean. All right, so theoretical probability is what should happen, while experimental probability is what actually happens. So if we flip a coin, we have two outcomes, right? Either a heads or a tails. Theoretically, if you flip a coin 10 times, how many times do you think you would get heads? Rhoda?
5.
Yeah. Theoretically, you should get heads 5 of those times and tails 5 of those times. Right? So it should be half and half, 1 out of 2, right? 5 times getting heads, 5 times getting tails. So how many students are in class today? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we have 25 in here today. If you each flip a coin 10 times, how many total flips would that be? Rhoda?
250.
250 flips. Theoretically, how many times should heads be flipped? Rhoda?
125.
Yeah, half of the total would be heads, the other half would be tails, right? That's theoretically. Do you think that's what's going to happen experimentally?
No.
Probably not, right? Because sometimes you might flip 7 heads out of 10 instead of 5 and 5, right? Theoretically, it should be this. Experimentally, it can be different. Could you flip 5 heads and 5 tails? Yeah. Is every person in the class going to do that? Probably not. Same thing with flipping a coin. We are going to do this experimentally now. We're going to each get a coin to flip 10 times. So you're going to get a coin. You're going to flip 10 times, and then we're going to record. So if you are doing this at home, because we have a couple of friends not here today, find a coin, and you can flip just like we are in class, but we are just recording what people in class get. I do need these coins back for next year's group. I use these coins every year. So you are going to put tally marks for how many times you flip heads, how many times you flip tails. All right, so flip your coins 10 times, marking a tally mark for the heads and for the tails. When you are all done, you can bring the penny back up front. Record then how many flips you had of heads and how many of tails. Count them up.
2 heads in a row. Tails never fails.
Oh, shoot.
Oh my.
Heads again. Head. Will this actually be 5?
Wow, some of us have some wild things going on.
I got heads.
Tails. Almost. Will this actually be 5? Wait, I just could be 5. Oh my gosh, I just put 5 and 5. Dude, I only did like 5 and 5 too. I got 5 and 5.
I'm getting to
Well, I need 5 and 5.
No way.
Dude, I got 5 and 5.
Yep.
What is the press looking?
I got 5 and 5. I got 5 and 5. I just want to get really. I got 5. I got 5.
Wait, I just got 5 too.
Leo. I got all heads. I got all heads. I got 5 and 5.
5, 6, 7.
We should be finishing up, so we can move on. Bring your penny up, put it in the bag when you're ready. All right. Voice is off now. You should count up. How many heads did you flip and how many tails did you flip? So remember, theoretically, you should have 5 and 5. How many of us actually made 5 and 5? There's a few of us, but not everyone, right? We didn't think every single person in here would actually make that. So what we're going to look at is our experimental probability versus that theoretical probability. We're going to look at our class results. Remember, there were 250 flips that happened in this classroom. 125 should be heads, 125 should be tails. So we're going to record what everyone got. So first I'm going to go around and you're going to tell me how many heads you flipped. And we're going to go in the same order because we're going to be doing this again with rolling dice. So when I call your name, you're going to tell me how many heads. Then we'll go back and you'll tell me how many tails. So we're going to start with the heads. We're going to go in order. Okay, so be paying attention so it doesn't take too much time. Audrey, heads.
5.
Leo.
5.
Mallory.
5.
So you should be writing these down as I'm writing them down. Charlotte.
7.
Zoe.
7.
Gigi.
5.
Moses. 4. And Haley.
5.
Shantrea.
5.
Gigi.
6. 4. 7. 4. 4. 4. 1. 5.
5.
7.
3. 7. 10.
You got all heads.
4. 5.
All right, now what we have to do is we have to add up how many heads were flipped in the class. So people take out your calculators, add them up. We're gonna take the one that the majority of us get because sometimes we add incorrectly. So everyone's adding up the heads with the calculator. We're not trying to do a mental math. Use a calculator, add them all up. When you get an answer, let me know. Gigi got 129. You got 129?
Yep.
Other people get 129? Yeah, okay. Now we're going to do tails. Same order. Okay? Audrey. Leo. Moses. Chantre. What was that, Evelyn?
6.
Ashley?
5.
Oh, 3.
6.
3.
Michael, did you have 3 heads and only 6 tails?
No. Oh, it's 7, sorry.
Okay. Matt, I'm assuming 0?
Um,
5.
And welcome, Maddie. You'll catch on to what we're doing. Okay, so take our tails numbers and add them all up. Raise your hand when you get an answer. How many tails were flipped in our class? Jackson, what'd you get? Did other people get 121? So we're going to remember what our theoretical probability was. We should have had 125 out of 250 for both heads and tails. What probability is that? 125 divided by 250. Rhoda? 50%. So for our heads, we had 129 out of 250. And for the tails, we had 121 out of 250. What is the probability of each of those? What's the percent? Who can tell me the percent for the heads? Fernanda.
48%.
And what is that percent for tails? Jack?
52%.
Now, if you look back up at your results, if you are one of our friends that got 4 heads and 6 tails, figure out what your percentage was. You had 7 heads and 3 tails. What was the probability percent that you got? So put your heads over the total, put the tails over the total, and figure out what your percentage was. How close were you to 50%? Now, obviously, our friends who got 5 and 5 were spot on with that 50%, but a lot of us weren't 5 and 5. How close did you get with your individual probability to the theoretical probability? What did you have, Rhoda?
70% and 30%.
What's closer to that 50%, your individual or the class? The class was closer to that theoretical probability. What about, was you 7 and 3, Rhoda?
Yeah.
And look at Matt's. Matt's would be 100% for the heads and 0% for the tails. He was really far away from that 50%. Right? 6 and 4 is going to be closer. What were the percentages for 6 and 4? Who had that? Ashley? 40 and 60. That 48 and 52 is still closer to 50%, even if we had 6 and 4. Okay. Now, we are going to do this with rolling dice. So, rolling dice. we had Maddie join us, so instead of 25 students, now we have 26 students. So theoretically, if you roll a die 120 times, about how many times should each number be rolled? If we're rolling a 6-sided die 120 times, what do you think, Rhoda?
20 times?
Yeah, because 20, 20, 20, 20, 20, and 20 adds up to 120. So you take the 6 outcomes and you divide that 120 rolls by 6. So each number should be 20 times. Does that make sense? So you take your total outcome, divide it by the possible outcomes, and that tells you how many each times you should roll. Now, like I said, we have 26 now since Maddie joined us. So if each of us rolls a die 120 times, how many rolls would that be altogether? What did you get, Rhoda?
3,120.
Now, if we are rolling that die 3,120 times, theoretically, how many times should each number be rolled? Vinny?
520.
Yeah, 520. We divide that number by the 6, right? Because there are 6 numbers. So now we're going to see what we get. Oh boy. So you are going to get a dice and you are going to roll it 120 times, marking a tally mark for each number that you roll. Trying really hard to make sure you're doing it 120 times. Then you're going to count up how many times you rolled each number. Shh. Remember, when we have big tally mark numbers, it really helps to do it in groups of 5. It makes the counting a lot easier rather than just lots of ones all over it. So do that 5th mark as a group. Okay. Then once you count those up, we're going to figure out your experimental probability versus the theoretical probability. So if you get, let's say, 10 ones out of 120, figure out that probability for your ones, for your twos, for your threes. So you're going to figure out what your experimental probability was, and we're going to compare it to the class. Okay? So everybody's getting a dice. Start rolling right away. Don't do wild and crazy rolls. Yes, it is a die. I'm passing out dice. Everyone gets a die. Or is that wrong? Is die plural?
Die is one.
Die is one. Okay. I'm confused. Yeah, I'm confusing myself. I think die is plural. Die is plural, dice is singular. So I'm passing out the die to everyone. Everybody gets one dice.
I rolled 4 one
And I know this because there is a game I just learned called die. And it's rolling 2 dice. You know what, I'm gonna look it up, because now I'm just second guessing myself all
I
over.
think die, like, if you say I'm gonna give someone a die,
Yeah, what's the best one had?
where is it like the deer thing?
Yeah.
Start rolling.
Because I am.
Yeah, I'm tallying. I'm not counting, I'm just gonna go for it.
game I was playing, we were passing one dot.
Then like this.
Doug, you really have to bring it up.
I'll place my bets on it.
That's just weird.
My dad's a professional dice player.
Why are you laughing when you eat it? Okay, I
You are one. My dad's a professional
Stop moaning.
I'm just gonna stop when I think Mr. Bottle Opener, I know who you are. Are we doing this whole back game?
Come on, guys, we gotta finish up. Keep going, keep going.
My friends and family. If I never see them again.
How did I go to 60?
40. I'm at 40 today.
I'm at 76. 59. Then 67. And now I'm back at 65. 78. How did I go to 71 to 60?
Oh.
I'm at 78.
When you finish, you're gonna bring your dice up, put it back in the bag, bring your binder up with you so I can fill in your numbers. We're just gonna try to make this as quick as possible, so bring your binder up. Okay. All right, what did you get for ones? You should have your numbers counted up, okay? Threes. Fives. And sixes. Hold on. 16, 21. Yep. So, my friends that finish, you come up, turn your dice in, tell me your numbers, and then you're starting to put these numbers in and adding them up. Jack.
Okay, now we just gotta count myself. Uno, dos, tres, cuatro, cinco, nueve, ocho, uno. 5, 10, 15, 20. 5, 10, 15, 20, 21,
You did not get all 20s for every single one.
5, 10, 15.
I've never seen that before.
Audrey,
your blood
pressure
Okay.
is insane. I get all 20s. 5, 10, 15, 16, 17.
Is yours?
Wait, do we have to fill ours out? I can't see it.
What? Oh, you can come up close, you can come up close to fill it in, just not, if you're filling in, not on this side, Claire. This is the side where people tell me, okay. Presley.
Oh, do we have to fill that in? Wait, Miss Gambino, do we have to fill
Yep.
that in?
So 20, 10, 30.
I don't know.
No, I don't know what I got. 22, 7,
Jude, can you recount yours for me? Because your numbers seem way off. Okay, Charlotte. You had 20.
Then you gotta put all them in the chart right here.
Yep.
Which one? How's the dome machine?
Same way I am. Write them down.
I can't tell which side I'm on. Oh, geez.
I'm sorry, say that again.
How am I gonna
Derby?
I'm going down.
19. Adrian, come a little closer. 20. Who else still needs to give me their numbers? Give me one up.
22.
Vinny?
Yep. I got 20, 20, 21, 20, 22, 15.
Who else needs to tell me numbers?
Me.
They're filling in all the numbers.
Oh, he's here. Michael. He's got to fill in all the numbers.
Zoe, did I get your numbers? You got them all counted up?
17.
Okay, get them all counted up real quick.
I have mine.
Come on up, Mallory. There's a lot of people up by me, so come closer so I can hear your numbers.
You sold me booty, dude.
We have 10 minutes.
We gotta write all this down in 10 minutes.
Yeah.
Jude, did you recount yours? Okay, because I'm thinking that your numbers are way more than 120 with what you gave us, so you might have rolled just a few too many times. Fernanda, did I get your numbers yet? Joy, did I get yours yet? Okay, let's get that done. Michael, get them added up real quick.
Wait, I forgot where it was.
Imagine someone's off by like
Okay, while we're waiting for those ones, friends, I'm gonna go through and I'm gonna read all of the ones.
Okay, good.
Okay, so listen for our ones. 50, 20, 16, 19, 14, 20, 21, 13, 20, 22, 20, 21, 24, 19, 22, 30, 25, 27, 22, and 10.
Wait, 25. Wait, where's 25? 19. 10. Oh, let me get 21.
All right,
Oh, wait, 25.
25, 27, 22, and 10. All right, twos I'll read a little bit slower. Matt, what do you got for ones?
I got 25,
Yep,
and then for twos I got 18,
yep.
7, 17, 42, and 11.
You liked those fives.
Yeah.
You dress matching.
Okay, for our twos, we have 32, 25, 21, 24, 24, 20, 20, 24, 19, sorry, not 19, 10, 17, 19, 21, 27, 24, 12, 20, 20, 15, 20, 20, 18. Then I have, for the threes, 34, 25, 27, 21, 17, 20, 20, 19, 30, 25, 22, 28, 20, 21, 22, 15, 15, 17, 21, 25, and 7. Okay, fours, 34, 20, 17, 18, 25, 20, 20, 20, we like fours, 25, 18, 21, 11, 25, 23, 20, 20, 25, 18, 20, 10, and 17. For our fives, we have 31, 20, 18, 18, 20, 20, 20, 16, 15, 20, 20, 27, 20, 16, 20, 17, 15, 18, 22, 25, 42. And our sixes, we have 40, 10, 22, 20, 19, 20, 19, 23, 20, 16, 24, 25, 18, 17, 24, 18, 20, 25, 15, 10, and 11. Now, we can see that some of these are way off from that theoretical 20, right? Some of us got right on with 20, but a lot of us are off. I'm going to give us a spoiler. Instead of adding it all up and figuring it out, I'm going to tell you that it is way more closer to theoretical. Experimental probability is going to be closer to that theoretical probability with the whole class versus yourself. We have lucky ducky Miss Audrey who had 20, 20, 20, 20, 20, 20. She made it. Nobody else did, right? You were off. So the whole class is closer, just like with the flipping the coins. The whole class, when we add them all together, is going to be closer than doing it yourself. So having that 3,120 rolls gets you a lot closer theoretically than your 120. So that brings us to our law of large numbers. The more times you do something, the closer the experimental probability T gets to the theoretical probability. And and I'll step out of the way in just a moment. So the more times you do it, the closer to theoretical probability you get. So for those of us that like to play the card games, when you go to a casino, does anybody know the rule of the casinos? What do people say?
No, I don't know.
The house always wins, right? So if you go to the casino and you win big, are you close to that theoretical probability? No, theoretically, the house is gonna win, the casino will win. So the more times you play, the more you're gonna lose. So if you win big, walk away with your winnings. Don't think, ooh, I'm on a hot streak, I'm gonna keep winning, I'm gonna keep winning, I'm gonna keep winning. Because the more times you do something, the closer to that theoretical probability you get. We don't have to do this part because we ran out of time, okay? It is your responsibility to know those definitions. Theoretical probability, experimental probability, and the law of large numbers. Right? You're going to want to put that on your help sheets.
Wait, do we have to fill this part?
I just said no. Okay? So you need those definitions on your help sheets. We can go over it a little more before we take the practice test on Tuesday. All right? Go ahead and quietly pack up and head to ELA.